Okay, good morning, afternoon or evening all. Welcome to the Understanding Players session. In today's virtual room we have myself as session chair, so I'm Ruth Falconer from the University of Abertay, Scotland, where I head up the Games Technology and Mathematics division. So warm welcome to the panel speakers. Thanks a lot for giving up your time to talk at this event. We've got a great speaker lineup talking about various efforts in understanding players and creating better player experiences. So before we kick off with some talks, just some housekeeping. So we'll have all of our live Q&A with all of the speakers at the end of the session. So we encourage you to participate by posting questions. So please, as they arise, drop them into the moderated Q&A and upvote any you'd especially like to hear answered. So first talk is by Josh Menke. So he spent the last 15 plus years designing skill, matchmaking and ranking systems, primarily for Halo, Blizzard and Call of Duty franchises. So over to Josh, who'll talk a bit about machine learning for optimal matchmaking.
Hello, thanks for inviting me to come speak here today. I'm glad to be here. I've spent quite a bit of time in the area of skill and matchmaking and ranking, but ironically, up to about a year ago, I hadn't actually worked on applying machine learning to matchmaking. So I actually also have a machine learning background. And some of those of you know me might be like, well, you do all that skill stuff. That's machine learning, right? And yeah, that is machine learning, but that's not matchmaking. Matchmaking can be done without regards to skill, and skill can be estimated without any matchmaking. But I'd not actually had a system that used machine learning for the actual matchmaking part of the process. And to be clear, I didn't actually produce the technology we have now that I'm going to explain today. That was done by Tom Minke and the TrueSkill team at Microsoft Research Cambridge. So I've been more the consumer on this side, just having lots of good discussions with them about where some of the lacks are, where we're lacking in matchmaking. And so now we've used this for about a year now in Halo 5, and it's also been really great. We're now able to make matches that are more fair than before, and we can do that without having to worry constantly about whether we're at a high pop time of the day, a low pop time of the day, what the latency is like, what seasonal effects we're having because of holidays or school just started. We're just able to encode what values, what matters to our players into this system I'll describe. And TrueMatch just takes care of it all, helps them stay engaged. And with the results that over the last year, we're actually up in our population year over year, which is not something I've seen in like almost any Halo that I can think of. And of course, the pandemic has had a hand in this, but I feel like we've been able to retain a lot of these players compared to what we'd have in the past, because with these different shifts in population because of the pandemic, this system is just naturally adapted to it without us having to tweak it to give the very best matches possible. So to talk a little bit, go a little more detail here about what I mean by matchmaking for those that don't know. So matchmaking is the main way players find other players to play against and with in competitive games, and also non-competitive games. But basically, that's what I mean by matchmaking. Like you have players that are searching to play a match. They submit some information to the matchmaker about themselves. The matchmaker looks at this information and using that decides to place them into teams to play against each other in fair matches. And so that's what matchmaking is. And then why would we want to use machine learning with such a straightforward process? Well, these matchmaking algorithms that we all use today are still fairly complicated, still require a lot of tuning, which today is done by hand. We have designers and engineers and data analysts look and say, hey, we're having issues with skill in this part of the world. We're having issues with latency, with these players are having a bad experience. Let's go in and tune them every now and then. Whereas we can use machine learning instead to automatically tune all of those parameters from the data rather than having to manually have this long process of review and figuring out what needs to be tuned. So let's talk at a high level how this all comes together and motivate it a bit by showing how matchmaking works over time. So you've got your matchmaker, and as time goes by, a player comes in and says, hey, I would like to matchmake. And so the matchmaker takes note of this player and doesn't have anyone from them to matchmake with, so it waits. And then another player comes along. And this second player, the matchmaker looks at the second player and looks at its own set of rules about how to matchmake and says, no, this would not be a good match according to these rules I have, which tell me what a good match is, so I'm not going to put those two players together. time keeps going by, and then eventually another player comes in, and the matchmaker says, well, that's not a great match either, but now he's been waiting for a while, and I just need to make this match happen. So not a very good match, longer wait time, but hey, let's make the match. Then a fourth player comes in. This fourth player turns out would have been a great match for player one, but it's too late. Player one's gone, and because he's kind of like player one, they're not very good for player two either. But now player two's been waiting a while, so we make that match anyways. And this is sort of like a very common occurrence that you have a matchmaker. It has some rules about what's a good match, and then it relaxes those over time, resulting in eventually a lot of suboptimal matches as well. But if somehow the matchmaker knew that player four was going to show up, it could have held player one longer. It said, wait, don't go yet. There's someone coming, and we'll matchmake you with them instead. And in general, if the matchmaker can predict the future and decide who's coming in the future, it can treat that future audience as the current audience and just use classical like combinatorial optimization methods to just do regular optimization to figure out what the best matches are going to be for everyone. And so the whole gist of this, the technology in this talk is, let's do that. Let's get machine learning. Let's predict the future, and we'll just do classic optimization on that future that we expect and result in better matches. So to give a little bit of an idea of what's going on inside the matchmaker, you basically have this set of rules, and the matchmaker looks at this information about both players or well, groups of players. But when it's deciding whether this match works or not, it's evaluating a rule and saying, for example, in this case, hey, can Bob play against Alice? Well, is the skill gap between them less than 10? And it is. It's 5. So because of that, this particular rule passes. And that's what I'm just giving that as background. That's what the matchmaker's made up of, several rules that cover fairness, that cover latency, and other aspects of the game. Now, another thing to kind of prepare us for the discussion is there's a metric we use a lot in how we evaluate matchmaking called predictability, which is basically just, hey, I've got a skill system that tells me how good each team is. And predictability is how often does the better team win? Because if the better team is winning all the time, then it's not very fair. The match is way too predictable. And so you want to aim for about 50% in terms of perfect fairness if you could. So that's like a primary measure of fairness that we use. And we found in our experiments in our data analysis on matchmaking that fairness is a high engagement vector for our game. Like unfair matches does result in more players leaving the game. And to kind of motivate kind of the issue with modern matchmaking, the high level, so here's some graphs. The high level idea in these graphs is population swings high and low throughout the day. And this happens regardless of how big your population is. There's going to be swings top to bottom. And I've seen this everywhere I've worked, Blizzard, Call of Duty, Halo. You have these swings from top to bottom. In this example, it's a very large swing. And with classic matchmaking, that whole notion of we're just going to expand, we're going to have some rules and expand over time, that makes it so that the actual quality of your matches is going to mirror your population very closely. If you have high swing in population, you have a high swing in what this right graph is, which is wait time. As when pop goes down, you have a long wait time because you're waiting, hoping that you're going to find a better match that's just not going to happen that time of day. Similarly, you'll end up with predictability having a high swing. You've got more fair matches during higher pop times to very unfair matches when your pop goes down. And likewise with latency, players will start having pretty bad ping towards the wee hours of the night there, and to go along with that population shift. And all of this is not ideal. You'd rather be able to have some more control over just how large those swings are, so your players have more consistency. And even more interesting, besides just those swings, is what this graph represents. So what we're looking at here is, this is a snapshot of just one specific time of day, and we're looking at this curve which shows the trade-off between how fair can we make a match. That's the predictability on the left. We want that to be low. Lower is better. And how long it takes the players to wait to get a match that fair. And it very clearly kind of has a knee at around maybe 2 minutes. So after about 2 minutes, it's not really worth forcing players to wait another 7, 8, 9 minutes just to get 1 more % of fairness. But if you set your matchmaker to a fairness threshold, that's what you're going to do. And that's going to make players wait really long periods of time if you have no knowledge of what this graph looks like. So you might be thinking, okay, well then just optimize for that knee of the curve and optimize your matchmaker to not wait longer than that. And that's a good idea. except this is just, again, like this is like 12:01 or something on a Tuesday. What happens at 12:30? What happens at 12:45? This graph changes hourly, or if not every 15 minutes or so. And so you need to re-optimize over that graph. And those of you in machine learning are probably thinking, okay, so you've got some kind of big hypersurface that that you can optimize over all day long. And if that's what you're thinking, then yeah, you're getting pretty close to kind of what we're doing here, in a sense. We're trying to, and I say hypersurface because it's not just one dimension. This is just predictability. You also have latency, of other issues. You want to have some kind of general way of optimizing. And so the way we do that is we first need to define optimal. So we're gonna come up with a utility function. We've spoken in this conference already a few times about reward functions. It has that same kind of idea. We need to put a number on what we think is optimal. We also need to look at real-time statistics. We can't just come up with a set of rules and hope they work all month long. We need to look every hour, every 15 minutes at what the population looks like. We need to use some machine learning to try to use that information to predict what we expect to see next. And then once we have those pieces, we can optimize over them in just standard optimization methods. And that's I'll try to get a little more information on that, although I can't go super deep given the time, but we'll hopefully give you a taste to feel how fun it is. So first, yeah, we have to define more specifically what optimal is. So this is where your designers come in. This is where we come in as game developers, and we say, hey, this is what's important to us. We think players care about wait time. We think they care about fairness, so a skill gap. Equal win rates is this subtle way of saying, like, who are we fair to? Are we fair to the good players? Are we fair to the bad players? Are we equally fair to everybody? That's something we can worry about. And then, of course, latency. Halo is a fairly latency dependent game. If there's a lot of latency between when a player shoots a bullet and when that bullet arrives on the server, then it makes it hard for players to play correctly. So combining all those pieces together, we end up with a system we've called True Match. It's kind of following like the true skill nomenclature there. And before I go deeper, I'll just give a high-level comparison now of what you get out of True Match compared to what you get out of more classical methods or kind of conventional matchmaking. First, of course, the tuning's automatic because we're using machine learning. The tuning's also like minute to minute rather than like the typical, hey, we haven't tuned our matchmaking in a month. We're getting some complaints. Let's take a look. It's True Match, the way we use it, tunes by region and skill buckets. So everybody of a specific skill within a specific region has their own kind of customized how your matchmaking is going to work, whereas most matchmakers won't do that. Because of the machine learning predictions, we can also tell a given player, give them a customized prediction about what their experience is going to be like. That's often maybe in the form of I can give them a customized wait time estimate. Tell a player you're going to wait about 2 minutes to get a good match. And also because we have those predictions, we have expectations now. And then when you combine expectations with what actually happens after those expectations, we can do monitoring and alerting based on those disagreeing with each other. And a nice little automatic monitoring. And yeah, this launched with Gears of War 5. It's in Halo, and it's also in Halo 5 now. So real quick here, this is just another way to look at that sort of objective function I alluded to. We have weights over all of these aspects, wait time, skill gap. We tell the system what we care about. They'll just get summed up into our utility function. And to make this easy for designers, these weights are just in terms of wait time, in terms of seconds. So wait time, we always hold that weight to be just 1. And that means that the skill gap weight is literally like 1 second I will trade off against 1% of fairness. Latency is I'll trade off 1 millisecond of latency for 1 second of wait time. We can do all that very straightforwardly, which makes it easy for design to reason about those. And here's the high level of how the algorithm itself works. It's going to count the population right now. It's going to using that information and using its ability to predict the future and its optimizer. It's going to choose the best rules to matchmake with and send those rules out into the wild. And then it comes back and tells us, we come back and tell the algorithm what happened, how well those rules worked. And it measures those results and uses that information to update its ability to predict what's going to happen. And so you got 2 nice sort of adaptive aspects. First, it's adapting real time to your population as it chooses the rules. And second, over extended amount of time, it's also able to continually improve its internal model of how all those things affect utility. So we've noticed over time that it'll solve problems that we've never been able to solve before as it learns how to better optimize to each region and each player. So it's pretty well done. To go a little deeper into those components, those, and I got to go kind of quick here, but you've got a population tracker, which takes in all the requests, all the tickets for matchmaking. It converts that into just a model of the population. And that goes into a kind of a black box predictor here, which that's kind of your machine learning module there, which is taking in both the rules that we currently have in our matchmaker and the population model and predicting, okay, well, this is what your utility is going to be based on my model of the world. And so within a run, it can tell that back to the optimizer, which can then say, well, we can do better than that, and continually go through this loop of suggesting better rules until the utility converges to something better. And then it'll stop and report those as the rules to use right now. And then, like I said, eventually it gets back how well did that work, and it's able to modify the metric predictor. It kind of used the machine learning aspect to improve how well it predicts that expected utility and get even better rules and even have it be even more closely connected to reality. And so you're probably wondering, like, how is it creating all these magical rules you use? This is like a little bit easy to demystify. The rules really are just, we actually make the rules. They're like skill gap has to be less than 10, for example. The difference is instead of saying skill gap less than 10, we say something not exactly, but hand weighty here, like skill gap is less than X. And so we end up with a bunch of rules with a bunch of X's and Y's and Z's in there that need to be picked. The optimizer, it chooses those X, Y's, and Z's. So basically it's doing a search over a parameter space, a vector of numbers. And so at that point, all you're doing is handing an optimizer a utility, which tells you how good this set of numbers are and those numbers. And you've reduced all of this problem of optimal matchmaking to just your standard optimization. So those machine learning folks, you can grab your favorite gradient ascent algorithms. You AI gaming developers, you can use A*, some branch and bound, just to search that space of numbers for whatever gives you good utility, and that works pretty well. Now, to kind of illustrate how this can be really nice, I want to talk about how this helps solve problems with region matchmaking. And I'm going to go a little fast here through this, but so commonly when you have a player in a different region, say in the EU, let's say she wants to matchmake and she wants to find a match to play right now. And the conventional approach is she's going to say, I only want to matchmake in EU because that's where I am and I'll get a better ping. So this is like fishing. She drops a net into the EU pool, hoping to find 7 other fish so she can play a match. But what happens is there's not enough people in the EU. And so after 5 minutes, it times out and tells her, sorry, there's no match. And so she just wasted 5 minutes there. And so what she does then at that point is say, well, I still want to play. So she takes her net and goes into the US pool and eventually does get 7 fish, settles for worse ping on a US server. But again, she's getting worse ping and she wasted that initial 5 minutes finding out that there wasn't going to be enough people. With True Match, instead, it works more like this. She puts a net into both pools. The nets have different sizes based on the statistics that the True Match already knows about those regions and her skill. And then she simultaneously fishes in both pools. And as soon as the 2 nets fill up with a total of 7 fish, she match makes, which means that, okay, maybe there still isn't enough people in the EU and she has to play on a US server, but she hasn't wasted 5 minutes finding that out. Or also she has a chance that maybe she will get enough EU players to pull the server onto the EU side. Definitely more often than the other approach where players are kind of manually guessing where they should be searching. So that kind of gives a sort of quick view of the type of thing we can do with True Match, at least when it comes to regions. And this is just me saying that all over again. So here's also an example of this working real time in Halo. In our free for all playlist, this is not this is a less popular playlist for us. So the request rate from players can vary greatly by time of day. So if you're running a smaller game and you think, well, True Match is probably overkill for me, this is actually shows that it's really good even for much smaller population games. So this is showing how much that varies. That's players coming in per second over time of the day. And what this is showing is how well the system worked. Like the yellow line is True Match working on that system, how well it's able to manage that utility, keep it within a narrow band. The blue line is if using our old school method, except let's say we knew the future, that we could make the perfect rule set, but we just can't change it over time. And that which shows that it can't manage the utility as well. Like it can't keep up when the pop goes down. And this kind of shows what's happening. The trade-off that's making basically is the feedback. Basically, that's our True Match method. It's saying, you know what, I'm going to sacrifice some fairness during this time of the night in order to make faster matches, whereas the Oracle, the static rule, it's not willing to sacrifice that, the fairness. And so it keeps that same fairness, whereas True Match is dropping the fairness by like 13, 15% or so. And the reason why is on this next slide, where you see that this is how long players are waiting on the y-axis there. The yellow, the true match method, is keeping their wait times to still well under 5 minutes, whereas the other method is shooting way up to like 15-minute type wait times. True match is cutting those wait times by like 72% by being willing to drop a bit in fairness. And I, as a designer, I would agree that's a fine trade-off. Like, we shouldn't be making players wait an extra 10 minutes in this case, just for that just 10% fairness in this example. And again, yeah, I can skip quick through this because that's just saying that kind of over again. So yeah, overall takeaway: you have a utility function to define your trade-offs and wait time. You have a metric predictor that can give you customized predicted wait times. You have an optimizer that uses those real-time stats and feedback to create optimal rules, and you get real-time optimized matches all day long without your designers having to worry about it. Designers can think about the big picture, like what's important to players: skill, latency, region, language, whatever it may be, and then you just let the matchmaker deal with balancing all of those. So just to kind of give a recap here, I guess what I feel like part of the biggest opportunity with this method is it flips the usual feeling of how players feel when they wait for a match. It gives the more intuitive, if you wait longer, it's going to be a better match because it means the system has decided it has something better for you, so wait. If you get a short match making time, then it's because no, there's nothing better, so go ahead and play. The other really nice thing about this is it can give out wait time estimates, which is, yeah, a lot of games give out wait time estimates, but they're usually kind of a global, averagey, sliding window thing. This is you can tell a player how long they're going to wait, customized to their skill bucket and their own region to give them a lot more information about what they're up for. Now, the biggest challenge I would say in this area, just in this whole general area, I think Kat alluded to this in her talk yesterday, which is there's this bottleneck between research and getting research into games. And in my experience, working with, at least with Microsoft Research, is they can come up with solutions faster than we can integrate them. So it's that whole navigating that, figuring out how do we get game studios to be able to set aside time to integrate these features. And by integrate, I mean like they're ready to go, like they're ready to be put in the game now. It's not a matter of waiting for the R&D to be done. It's ready to go. It's just the studio ready to integrate those APIs and whatever it may be. So yeah, so anyway, thanks for listening. If you have any more questions, if you have feedback, I put an email address there. It's trueskill@Microsoft, even though I talked about truematch@Microsoft.com. We are kind of Microsoft Research always kind of has their feelers out to see what the interest. Like, this is currently an internal only service, but we always have our feelers out to see what's the interest externally. So if you have any interest or feedback, just go ahead and hit them up at that email address. And that's it. Thank you.
Great, Josh. Thank you very much for that. So the next talk is by Magy El-Nasr, who's based at the University of California. So she's been developing automated tools and techniques for authoring, adapting and personalizing virtual environments, and developing evidence-based methodologies to measure the effectiveness of game environments. So her talk's entitled Game-Human Interaction, Developing Methods that Capture the Player Experience. So over to Magy.
Hi, thank you so much for the introduction. Hopefully you're seeing my slides. It's taking a while to show up. Okay, so I'm Magy Seif. I'm a professor in the University of California, Santa Cruz. I'll be talking a little bit more about capturing the player experience and modeling it. I wanted to first start with acknowledging all the people who have been working with me on the work that I'm going to be presenting today, including my postdoc and several people who PhD students are on the northeastern side, which I just moved from, to some people also in the UC Santa Cruz side, as well as alumni and funders who have funded my research. So I wanted to start by basically discussing why would you want to capture and model player experience, and specifically I'm going to be talking more about deep player experience modeling. So not just the prediction models, but more deep analysis of player experience. And so why would you want to do that? There's a lot of reasons, and we've seen in the talks that was yesterday as well as today some of the applications of modeling player experience. But one of them is, for example, you can tune the design, which has been discussed in the Game Developers Conference at length. You can also use it for content development. And recently, there's been also a move towards building playtesters, AI-type playtesters that can mimic humans for playtesting different games. You can also use it during play, like for recommendation systems, like matchmaking systems that we've heard about. Also, developing opponents or teammates, sidekicks or coaches. And we are also looking into using these particular models for training competitive play, like esports. There has been a lot of methods understanding the player experience at the depth that I'm talking about within fields like the game user research. And within game user research, there's a lot of work on like playtesting and qualitative methods with interviews and surveys and playthroughs and callouts and so forth. There's also a lot of people who have looked into measuring the play experience from an affective perspective using sensor data, or looking at attention methods, looking at how people are moving their gaze around and attending to different aspects in the environment using eye tracking methods. In the recent years, and I mean like between 2011 until now, there's been a lot of movement in using game data to also understand the player experience a little bit more. In 2013, we published a book basically interviewing many different people who have started to use game data in their processes, different industry as well as academics. So game data science is like data science, looking at ways of collecting, storing, analyzing, and communicating data. They use a lot of different techniques, from statistical techniques to machine learning, AI, and visualization. The data that's collected is a lot, and I'm going to talk mostly about player action data in this talk. But there's player action data, mostly we call it behavior telemetry. But there's also a lot of other aspects of data, like server data, process data, workflow data, as well as user data. So about preferences, and maybe beyond behavioral data about the target market itself. In this particular talk, I'm going to focus mostly about the player action data, because that's what we are interested in terms of the player experience. So how do we model player experience? So most of the time, people have logged basically all the data that people are doing, and they log and get in a telemetry database. And then you could probably use machine learning algorithms to kind of look at what the latent variables are, or maybe model the process a little bit. What we're interested in when we talk about deep player experience modeling, we're interested in understanding a little bit more about the heuristic aspect within this data, like what strategies do people take, what mental models can we tell from this data, how do they change their behavior over time, maybe in reaction to the environment, or to cope with errors, whether these errors that they do or errors in the game itself, and how do they problem solve within the game. Now, if you can tell, all of these different questions require a little bit more understanding of the contextual details, cognitive elements that may not be present in the data, may be hidden in the behavioral data a little bit more, and also accounting for variability. Since games have been very broad, we're looking at variations in behavior, and so we want to harness these variations, understand them a bit more, understand the individual differences. So another way of thinking about it is, instead of using machine learning and kind of losing some of these individual variations, maybe what we could do is process the data and visualize it. And we've tried that too. We have been working on this kind of problem for a long time. We've collaborated with different industry partners. One of them is on a game called Was It Trouble with Brainquake? And they gave us different data logs, and we started to look at ways to model the players. And so we tried to just process the data. Now, again, figuring out how to make sure that we account for context as well as individual differences. So what you get, if you just visualize that, is a hairball. So something like that. So this is really hard for us to make any sense of as humans. But even for machine learning algorithms, this one's really hard. So instead, and basically the issue is that telemetry data, it kind of has in it a lot of contextual aspects. The behaviors are happening in very context-rich environments. They are also very highly dynamic and highly dimensional. And there are many, many unobservable variables that are kind of inside or packaged inside of these telemetry data in terms of the cognitive variables that people use. So how will we unpack that? We tried another method using reinforcement learning, actually inverse reinforcement learning, and a lot of people in audience here are actually familiar with reinforcement learning. Now, our approach, we looked at a puzzle game like Was It Trouble, which is actually a very simple game compared to something like esports games, which we have also modeled. But just taking a puzzle game like Was It Trouble, we used inverse reinforcement learning, but again, it was really hard to use it to understand the underlying, all of the aspects that I said about like the underlying individual differences, the variations, and how people are moving through the space of different solutions. And the reasons is because people do not basically try to optimize on one reward in a game. They actually move quite a bit. And sometimes their behavior is very opportunistic. They may be going after one goal, so they'd be doing something, and then they say, oh, but I can achieve that other goal. So they move on to the other goal and then come back to this goal. So they optimize on where they are, and they behave very contextually and opportunistically. And that's really hard to capture using something like inverse reinforcement learning as it currently exists. So instead, we started to build a new approach to modeling this player experience. And the approach basically is more like a human-in-the-loop approach that integrates interactive visualization with machine learning in a humanistic kind of model. And I'm going to describe what that looks like. So that's kind of like the infrastructure of what the model that we have developed. And the idea is that you have a lot of log data coming in and some kind of process that tries to abstract the data from the very low level. Maybe it's mouse clicks, maybe it's hover overs, maybe it's eye tracking data, maybe it's other kind of data. And you're abstracting it to something that you can then visualize. I'm going to talk a little bit about the abstraction method. So different games come with different complexities. An example is Dota type games, and we have been looking at Dota data for a long time. And with Dota, you have a spatial temporal element. So it's not just puzzle solving, it's contextual details about the environment itself that enables different things that you're doing, where your team members are, and so forth. So there is some contextual details that allow specific opportunities to happen. There are multiple people have been able to abstract the behaviors and the strategies that people do in esports to things like, oh, this is a baiting behavior, or this is a ganking behavior, or a laning behavior. And these are more higher level behaviors than just like movement in space, right? So we wanted to basically use the label, like a human approach to label this data. So we developed a visualization system called StratMapper to do that. And I'm going to show you what StratMapper looks like.
Here we are in Strat, visualizing data from a portion of the match in the game Dota 2. At the center of the application, we have the two-dimensional game map, which can be seen.
So I'm going to lower the volume for the video so I can talk over it. So you have here a Dota 2 map. It is an older data set from Dota. As a lot of players, if you're a player of Dota, you probably have known that. There are two different teams. Usually in these type of matches, you have teams of 5 playing against each other. So in the visualization, it's basically an abstraction from the video of the game. So you have the game map here, but you have events are happening over time. So you have a timeline here, and you have all the events that are happening that we collected from the data that's abstracted here. And you can move over. So this is, you can hover over the different events as he's showing here. You can also get a specific time spot, and you can see the movement. You can play the movement over time. You can also start filtering things like filtering specific players out, maybe muting specific events. making specific events more predominant. And then we started to use this tool to allow people to label specific events that are happening. So they can say things like, this is a baiting behavior, and it involves these two people, and it involves these particular features within the data set. The different people can then label different events, and then we can do some more inter-rater reliability. So it's kind of like a qualitative coding of what's happening, but allowing us to get a higher level view from what the human is thinking is happening, and using all of these particular features. So in an essence, what we were able to use this visualization method to kind of do a human-based approach to understand the context, use domain knowledge from the human to abstract all of the strategies that are happening, and in some sort of a feature selection type of way, because we can filter these events, filter the players, and so forth. So we're basically using the human as an approach to do feature selection as well as abstraction of the different players through this particular visualization. And then once this comes out, then we will filter all data, and you have more abstracted data rather than having movement in space. You have things like baiting. This is what happened here by these particular two players, these particular actions, and so forth. And then using that, we built another visualization to allow us to look at sequential behavior. So now that we have behaviors, we can then start to look at sequence of behaviors, very similar to an MDP or other types of techniques. And in this particular visualization, we abstracted the data into the different states and actions that people are taking, very similar to an MDP process. So everybody starts in the same state. This is your blue state here, and this is a was it trouble game. It's a puzzle game, so people do different actions to move from one state to another, and then they get to an end state. They may all get to the same end state or different end states, and they may go into different intermediate states in the middle, and they may take different actions or behaviors to get there. We built the visualization system Glyph to basically be able to visualize these patterns from many different players. So this is like almost like 100,000 either unique players or people who have gone through that particular level. The bigger the node is, it means more people went through it. The bigger the edge is the same thing, more people went through it. So as you can see here, there's a dominant way of solving that particular level. But then there are other also ways to solve that level that gets you to three different end states. We supplemented that particular window with another window in the visualization system that allows us to look at how different these sequences are. And this is where we can model or understand individual variations in the data in terms of problem-solving behaviors. In this particular view, every particular node is a pattern. And so the big one here is the big one that you have here, which are two actions to get to the end node. And they are clustered, or they are basically drawn in space, and the distances between them is how different they are. So the more different they are, then they are spaced out, so you get a feel of a clustering. We're using dynamic time warping as a method to kind of understand the differences between the different sequences that are happening. So there's some underlying mechanism to kind of understand distances. And then you get different clusters. It's an interactive visualization system that then we can interact with it to kind of see the differences of how many people have gone through this blue, for example, pattern versus either the green or the red or the orange pattern. And you can also see what actions or behaviors the people actually do to get from a start to end in each one of these different clusters. And you can go deeper into the actual actions or the different behaviors that people have done. This allowed us to understand issues of pacing, which is hard for games, especially figuring out how to tune out the difficulty or balance the difficulty for the different people, specifically if you have a broader audience also involved. And so using a technique like that, we were able to tell, okay, majority of them got this level and they moved well from one level to another, but then there are some difficulty moving from one level to the other. So difficulty adjustment might be needed in a particular situation. We also extended the method recently to kind of look at how do we, so now that we can figure out what patterns people are doing or what strategies they're taking, can we get them more deeper into like why they're doing this? That would help us maybe to design better or maybe to intervene in different aspects of the game in a better way. So we wanted to get rationales for the patterns that players are doing. So we use the same method where we are labeling and looking at the patterns, but we added one single change. We actually added an interaction with the user where the analyst would basically look at all of the different patterns from the visualization system glyph, and then we figure out, okay, these are the patterns I want to ask about. And then they will go and talk with the user and say, okay, you did this. Can you explain a little bit more what you had in mind? And they will show them the visualization. This did two things. It allowed us to show the model to the player and allowed them to think about what they were doing and interpret the model. So it allowed us to also understand if people can interpret their own data using the visualizations that we have. But it also gave us a way of them reasoning about what they are doing beyond just, having a video playback. And in that sense, it's more scalable because you can understand what pattern, like if 100 people have done the same pattern, probably reasoning of several users might be similar across different users. So we did that for a particular game where we were able to develop, here's the patterns that people have done using our method. And then we were able to tell why people did this particular thing, particular patterns or behaviors. Some of them might be behaviors that we expected as designers, and some of them might be behaviors that were just not really what expected at all. And so one thing that we expected is people would learn from one level to another, and they were learning, and it showed that in the rationales when they were describing why they did this action, because they learned it in another level, which was good to see. But then there were also another issues that came out, like the mental models that they had about their interaction with the game was very different than what the designer intended. And that was kind of interesting to uncover using that particular process. And again, it might be just one particular player, but it could also be a group of players that had this particular mental models that were just very different from what was intended. And that allows probably designers to take it as something as a feedback to basically adjust the design. So in conclusion, I talked a little bit about just the methodology that we have been developing, which kind of integrates interactive visualization, a human-in-the-loop approach with some statistical techniques underneath. We hope to add a little bit more machine learning underneath, especially that we have people labeling some data. We could actually use the labeled data to scale up and look at different types of data as well and label these given the labeled data. One of the things that we wanted to do is basically make sure that the individual differences was preserved as well as the context was also preserved. So we were able to do that using that particular methodology. What I feel is challenges, or I see challenges and opportunities as the same thing. And all the challenges are going to become opportunities at some point. So I see this particular approach as a way to expand the modeling process to look at how we can embed human expertise with reasoning models and ML approaches, which I feel is going to be great at looking at more explainable and transparent AI models. We've also been looking into the idea of now that we're collecting all this data and we're doing all this modeling, can we open that model to players? So players can learn from the models. Maybe they can reflect on their own processes of thinking and their processes of problem solving to learn more about themselves and maybe more about how other players are interacting with the game. We also looking at using that for esports specifically to look into how people can use their own data to maybe train for different tournaments by fixing or adjusting issues within the team or within their own play, but also figuring out how the other opponent team would be behaving so that they can interact with them in a better way. That's kind of like where I would stop. So I want to again to acknowledge all of the people who have been working hard in my lab on various aspects of the models that we have developed. This particular model has been produced over maybe 4 or 5 years with small pieces as we move on.
Okay, thank you very much, Maggie. That was fascinating talk, and I really loved the use of the graphs to show the individual strategies of players. So thank you. So now we're going to move on to a presentation by Francisco and Abby. Both are part of the Minecraft group at Microsoft. They're interested in the use of data, insights and algorithms to improve player experiences and outcomes. So over to them to hear about Minecraft's transformative journey to personalize player experiences.
Hi, thank you, Ruth, and good morning, everybody. Thank you for joining. As Ruth stated, we're going to talk today about Minecraft's transformative journey to personalized player experiences. I'm Francisco Rius. I'm the head of data science and data engineering for Minecraft.
And I'm Abby Gaddis. I manage the data science part of our team at Minecraft.
And we're going to give you a little bit of context before we kick off. We're going to focus today on the thinking and decisions made to put Minecraft on this journey towards personalized player experiences, focusing on Minecraft Marketplace. We won't go into too much technical detail on the algorithm or data science side. We might have some detail onto the technical architecture. By way of agenda, today we're going to talk about what Minecraft is. It's very fun, a use case in personalization, and talk about key learnings around personalization, what we've learned so far. We also want to talk about how to apply strategic principles for a gaming franchise to personalization, as well as 2 upcoming initiatives in this space. We're also going to talk about technology pipelines as an enabler for these use cases in machine learning and personalization. And last but not least, we're going to present a big opportunity as well as challenges as it relates to this space. And before we go into detail, we do want to call out a few teams. Some of you are listening to us today, and thank you so much for joining. AGCI, MS Research, PlayFab, and a lot of other teams that have been instrumental in getting us to the place where we're at today. I also want to give a small shout out to my sister who woke up at 4 in the morning today from Australia to be here today. So sorry about that, but thank you. And we'll jump right in. So what is Minecraft? Minecraft is the original sandbox open world game. What this means is that it doesn't have a predetermined outcome. It's a sandbox where players can come in and create their own experiences, collaborate with others, engage with friends, or play solo as they want. It's a very diverse and global audience. We have over 120 million monthly active usage. And this means that we're not only diverse geographically, we're literally in every country in the world, but also our players are very diverse, all age groups, all sorts of demographics, psychographics, you name it. We operate in 22 different endpoints, at least 22 different endpoints. This means that we're present in console, Xbox, Sony, Nintendo, as well as mobile endpoints in iOS and Android, you name it. But if you're close to data engineering, you can see the complexities that we could create by way of ingestion of data from different technologies. And very important to call out, as of a few months ago, Minecraft became the best-selling game in history. I believe we surpassed Tetris a few months back. And we're going to give you some perspective and a little bit more detail around a small section of Minecraft, which is called the Minecraft Marketplace, where players can download and engage with content that can potentially be used to expand their experience within the ecosystem.
Yeah, so I'm going to talk you through a little bit about our marketplace. So what is our marketplace? So it's this place that we've made to surface content from our third-party creators, as well as some of our own content. It comes in both free and paid flavors. We have a lot of different content types, including skin packs that make your character look different, worlds where you can have a different kind of experience in Minecraft, and textures that make everything look different. And we've also got manual curation of the rows in our marketplace, and then we also have some that has been automated. So we started doing research into our marketplace to understand like where, which of these tiles in the marketplace are performing well. What can we learn from that basically? So we started to look at which of the tiles is doing the best. We expected that above the fold at the very top of your screen in Marketplace would get a lot of attention from players and that they would mainly monetize or click or look at that type of content that's featured up there at the top of the Marketplace. We did find that is true for the biggest tile in the Marketplace there in the top left that you can see. But the featured tiles to the right of it are not in the top 3 of our content that gets checked out by players. And even this new row that you can see down there towards the bottom was not at the top. So continuing to look down through the Marketplace, we can see that we have this row popping out recently. We've been talking, people mentioned some of the effects they were seeing from pandemic, like in the matchmaking earlier from Josh, but we also were seeing for Minecraft that there's this big interest in our educational content during the pandemic as we have kids at home looking for something cool to check out, maybe a replacement for that trip to Washington, D.C. that they do every year. And so this really high quality content that we've gotten with our education team is being surfaced here in this education row, and it's a really well performing row. At the same time, it's free, so that's another driver for why people would be interested. So continuing on down through the Marketplace, we saw that one of the best performing rows is at the very bottom, which is not something that you would think. It's not featured in any way. At the very bottom of the page, we have this recently viewed row. So some of this is free content, some of it's paid content. And it performs really well with the players. They are kind of like looking at these things, thinking about it, and then maybe buying that content. So what does this tell us about our Marketplace? So the recently browsed content is a very high performer. These data-driven versions of our curation have some of the best conversion rates. So for instance, like we have a trending thing that used to be manual, but once we got an actual, automated version of that surfaced, players like that a lot better. So our machine learning algorithms, or just our algorithms, simple heuristics even, were able to do a better job at telling what was going on with our players than we were. And that's also kind of reflected in the performance of this education row, where you've got these social norms and new things going on outside the game that maybe our manual curation might be a little behind on, where you need something automatic that is surfaced. So through some of these data-driven rows, we're able to see that technologically we can surface information that's going on in our database back to the players in the game client. We also are seeing through the performance of that recently viewed row that they want this type of personalized content. So we have the capabilities to take this to the next level. So let's talk about what is the next level.
So what is the next level? And it's a great question. One of the things that we've been trying to do is create strategic pillars for the project that also align to strategic pillars for the franchise itself. And we came up with 3 pillars to drive this project that closely align with what Minecraft wants to be as a franchise. The number 1 guiding principle for Minecraft, or one of the most important guiding principles, is that Minecraft is for everyone. We talked about the diversity of our players and recognizing that players have different needs, wants, and motivations for engaging with the game is really important. Trust is a huge element in our video game, as well as other video games, but specifically on ours, because we don't just cater to players in console that may be a little bit more hardcore. We actually cater to families as well, and we see, as Abby alluded to, players having an educational experience in our ecosystem. And player first focus. So this is realizing that the most important indicator for our success is really going to be whether players are having fun or are enjoying their experience with the game. And in order to achieve these strategic pillars for this project, we also are implementing what we are calling strategic heuristics. So a few simple steps to ensure that we stay closely aligned to our strategic guiding principles. And this includes taking privacy as one of the most important strategies or tactics in this project. We don't have any personally identifying information. We don't know names or anything like that in our algorithms, and that's not necessary for us to create successful algorithms. Also, thinking long term. This is a marathon, not a sprint. And one of the things that we like to think about is Minecraft has been around since around 2009. There's players that have been with Minecraft since the early stages and have seen their lives transition and transform as they grow in age and such. But they stick around and they stay with Minecraft, and even their experience evolves over time. So we think that the relationship with players is a long-term relationship rather than a short-term optimization challenge here. One of the things that we haven't really talked about is how do we understand, how do we get to the point where we can listen to players and understand what they're feeling, what they're experiencing? And for that, we actually establish a few listen mechanisms that are not necessarily KPI driven or behavioral algorithm or behavioral indicators of what they're doing in the game. So for that, we're listening on social. We're also doing primary research as well as other strategies in the game to try to understand what players are feeling when they're interacting with some of our features. And last but not least, we've talked a lot about reinforcement learning over the past couple of days. We're optimizing for 4 main KPI areas: discoverability, browsing behavior, engagement, and revenue. You've seen and you've heard the horror stories from different implementations around the world on machine learning and the responsibility that we have as data scientists to make sure that our solutions are also taking into consideration the potential for creating friction or negativity. By optimizing for player first indicators, we believe that we are taking the players into consideration and their diversity. So now I'm going to run you through 2 key tactics or features that we're launching pretty soon. I won't go into detail into timelines, but for those of you who are experiencing Minecraft and have experience with the Minecraft marketplace, I really encourage you to pay attention to this. In the Minecraft marketplace, we're going to launch a similarities engine. And basically what this is a related items row whenever you're browsing different content types. So these are similarities that we infer through the content catalog, whether it's through natural language processing, basket of goods types of methodologies or correlations. We are benchmarking multiple algorithms against each other to present what you have on screen is an example of Toy Story and similar content that has similar look and feel. You can see Steven Universe or Adventure Time that visually have very similar elements as that Toy Story item in your screen. At the bottom, it's something that's a little bit more specialized, and this is the holy grail. We're going to go out with player level recommendations. So if you think back at our KPIs, we have over 120 million active players every single month. So creating personalized recommendations for 100 million players is not just a game of or a challenge of creating very good algorithms to develop recommendations. It's also being able to deliver that type of recommendation at scale and processing data in near real time. So in the bottom of the screen, you have an example of ray tracing. Ray tracing is a new technology that launched with Minecraft in Windows 10, where basically the light for the game is a lot more realistic. It's rendered in a way that it's reminiscent of real life. And basically what we're showing here is one player that's enabled to use that technology consumed the color, light, and shadow map within the marketplace. And very quickly, our algorithms will pick up that player is enabled to play with RTX and will make recommendations based on what other players are also selecting in the game, and a few other heuristics as well as machine learning decisions to create a recommendation specific for that player. So the next thing that we want to talk to you about is using technology as an accelerator in this space. So one of the biggest things, and I've alluded to this, is we're good at building algorithms, and we've gotten a ton of support from different teams at Microsoft to build algorithms. But the biggest game changer has also been a re-architecting of our technology pipeline. You have on your screen a comparison before and after in our technology pipeline. Before, we were capturing a lot of telemetry in a telemetry cloud, pushing it to long-term storage. And then one of the biggest inefficiencies was that our data scientists were downloading data sets and then doing their computation in different clusters. And then there were like 3 or 4 different steps to get all of that information back to the game. By the time it got back to the game, it was stale or it was outdated, and it was very difficult to consume for the game services team to push recommendations back to players. So one of the things that we did that was a little bit of a step up in our technology architecture is we merged our data science and data engineering processes in this space in one single technology. So we moved to Azure Databricks, and that way we can collaborate as data scientists. So we have multiple data scientists collaborating in the same algorithm. But the best thing is they can actually talk to our long-term storage as well as push recommendations back to the game services so that that information can get passed to the players. And the really cool thing is that we're able to A/B test in real time. So we can change the algorithms. We have some heuristics around how we are A/B testing and using Microsoft technologies to A/B test. But we can test 5 or 6 different algorithms at any given point in time, if not more. And we're watching all of those to try to understand what the best outcome is going to end up looking like. So last but not least, I'll take a couple of minutes just to talk to you about the future. We see opportunities and we also see challenge. And the biggest opportunity is continue to recognize the diversity of our players. And the fact that they're not just diverse geographically, as we've talked about, but also their personalities and their wants and needs are very diverse. On the left-hand side, you have Alex, who sometimes likes to play Star Wars and sometimes likes to battle the mobs, sometimes likes exploring with friends. And those motivations will vary throughout the day, throughout the week, when it's a weekend. And then on the right-hand side, you have Steve, who sometimes likes to play solo, create content, or build a new world. We can infer some of these behaviors using key performance indicators, but also it's very important to listen to players and what they're experiencing, what they're thinking. And last but not least, what we see as the biggest challenge, and this is going to sound very abstract, but it's a very important question strategically. It's a balancing act between KPIs and potentially over-technifying the definition of a player versus our guiding principle that Minecraft is for everyone. Ultimately, it's really going to be very difficult to codify what players are thinking and what they're experiencing in a single KPI or a collective of KPIs that create an index. So we have to listen and understand that we need to read our performance indicators in a way that put players first. And stating true to the guiding principle that Minecraft is for everyone is a balancing act between potentially over-technifying some of these approaches through machine learning versus staying true to the guiding principle that is going to be a long-term approach. With that, we thank you very much for your time and we look forward to taking any questions. Thank you so much.
Thank you very much, Abby and Francisco, for that very interesting presentation. And it's really interesting to see how sophisticated the personalization can be. So that draws to the end the set of 3 presentations, and now I'm going to open up for Q&A. So I'm just going to have a look at some of the questions that were here, and I think the first question will go to Josh. So someone is interested in how does TrueMatch handle pre-made group of friends launching matchmaking together as a group?
So actually, it turns out TrueMatch itself doesn't really have to do much for this in our case, because TrueSkill, which is a separate system, a separate tool that handles estimating the skill of the players, it handles that. So when a player goes to matchmake, it asks on our end, the lobby service, the one that's going to submit the ticket for the player, asks TrueSkill, how good is this player? And TrueSkill says, well, is he in a party? What size? And then it modifies its belief about that player's performance in the match based on the size of the party. So TrueMatch will then just take that as that party's increases the party skill. So, and in practice, it works really well. Like we don't have full parties winning more often than expected.
Okay, great stuff. Thank you. And the next question then is going to be for Magy. So hi Magy, thank you for the presentation. I find the overlaps in the player behaviour patterns based on their primary types quite interesting. Have you based this on brain hex taxonomy or something similar of player types based on motivation by any chance?
Thank you for the question. No, we actually didn't. We drove it all from data. We are very familiar with all different player taxonomies, as well as we have done a lot of work with looking at personality and how it matches with these player types. There's also a self-determination theory for motivation. So some of these theories we have used to develop the techniques, but most of the techniques are not really assuming any of the behavior types. They are mostly data-driven.
Okay, thank you. Another question then for Josh. So while 50-50 matches tend to yield the highest engagement on average, have you ever investigated the impact of sequences of matches? So put another way, does variability in fairness, e.g. 60-40 but followed by a 40-60, 60 rather than two 50-50s, over time contribute to player happiness or satisfaction?
Actually, I have investigated this quite often, and the answer is it depends on how much variability there already is in the match. If you have a match that has a lot of variability already in it because of gameplay or because there's a lot of players in the match, then there's not often a huge benefit to forcing additional variability because you already have so much. So in Halo, in 4v4, each player already varies around their ability when they actually play a match quite a bit. So 4v4 Halo, even in a match with where the gameplay itself doesn't have a lot of variability, can still result in quite a bit of variability match to match with the exact same players, which is, you'll see at high-end pro-level Halo, as the same exact players play each other several matches in a row, the outcomes can be pretty different. Now in StarCraft 2, though, it was 1v1, and it was somewhat more, maybe you could argue, deterministic. And so in that game, to deal with that fact, rather than try to manufacture sequences, we experimented with injecting a bit of randomness into, well, not injecting randomness, we would lie sometimes about the skill of the player, resulting in a sort of random mix of different types of match difficulties. We found that players much prefer that they would still be mostly 50-50, but mixed in a few 60-40 and a few 40-60 just randomly, and that was enough. So anyway.
Okay, great stuff. Another question then for Magy. When moving to the visualization stage of data, is there any particular way that you or your program chooses that data is meaningful to determine player behaviors?
Yeah, so depends on the game and the data. Some data has already been processed. So if you don't have, like some games, we get things like mouse clicks and movement and other types of maybe even missing data. So we do a lot of processing in the beginning to kind of make sure that the data is clean, that there are different behavioral data in it and not just contextual data. And if there isn't contextual data, we could try and infer some of that if it's available in the game to kind of infer game state. So there is a lot of processing that happens in the beginning before we actually put everything through the visualization system. But sometimes we also get the data from the companies or from the APIs in a way that we can actually feed it into the visualization directly as well.
Okay, great stuff. So the other question I have again is for Josh. We're going to get some for Abby and Francisco in a moment. So one of the challenges we have faced over the years is the more optimal our matchmaking algorithm is, but it doesn't translate necessarily into a better player experience. An idea that they've considered is looking at different axes outside the ping and skill. Have you considered anything similar, Josh?
Yeah, this is another one we spent quite a bit of time looking into. There's always that, I think there's this like source of sweatiness where, hey, every match is so tight. Are the players feeling sweaty? And I've actually found there's a couple of sources of sweatiness. It's not just that the match is so fair that it feels sweaty. A lot of times it comes from the putting players with in a match where people on their team are very different than their own skill. So what happens is you have a match that is fair in terms of the team balance, but Team A has a player who's amazing on it. Team B is average players, and so all of Team A's teammates, in order to keep things fair, are all kind of poor. And in that case, the great player feels like he has to carry his entire team, which results in sweaty matches. That has been, in my actual investigating of these complaints, that has been usually where most of these sweatiness complaints come from. So in Halo 5, in True Match, we have actually two types of fairness values in there. I didn't go over both of them. One is the team balance. The other one is how different am I from everyone else in the match? We just cranked that one up a lot higher, and most of those complaints went away because it resulted in your teammates. It very strongly tries to get you equal-sized teammates. So anyway, if just to say real quick, if you have more questions that I can't answer about this, hit up that trueskill@microsoft.com email address or hit me up on LinkedIn. Also, if you go to gdcvault.com and just type my name in, there's several free talks on all these topics.
Okay, one last question then for Abby and Francisco. I guess, your last slide, you talked a bit about opportunities and challenges. I guess, what do you think is the most important opportunity or challenge in terms of priorities?
Yeah, I think there's a few opportunities. The big one, which sounds really abstract, but we believe it's a very tangible challenge, is really the recognition that all of our players have different needs and motivations to engage with the game, and they're in the game for a reason, but it's very hard to codify that in a single performance indicator and actually create algorithms that recognize that and serve recommendations to create that experience because they're feeling something. And most of the times we're really just creating KPIs that are trying to get to some of those motivations by proxy, like engagement or retention or revenue. So maximizing that is a balancing act from a machine learning standpoint, whether we are codifying very discrete types of measures for the problem that is really behavioral and psychological in a way for players.
Yeah, good point, good point. I think we can squeeze in one last question for Josh. So the question is, what is the process for small studios to use the True Match system? Is there even a way to access this system as an outside studio at this time point?
Yeah, so right now it is internal only. And if you are interested in using it as a small studio, my best advice to you is to hit that email address, trueskill@microsoft.com, not True Match, TrueSkill, and give feedback there. They're always looking for measuring that demand because it's something. I mean, I personally feel like it would be awesome if there was a wide access to that as a service for people. So yeah, hit up that address so they can track exactly how many people would love to have it. And I'm glad a small studio would be interested in it because it makes a huge difference, even almost especially in small studio cases, because you're swinging so much up and down day to day in population, and you'd really like your matchmaker to be able to give your players really quick matches despite those population swings, and it's really good at doing that for you. And then as soon as your game takes off, because your small game is awesome, it'll just naturally catch that population growth real time for you and give even better matches. So yeah, hit them up. Let them know so that I say them because I'm not actually part of the team that develops the tool. I use it a lot. I love it, but that they would definitely want to know your interest in that. And I think that the more of you give them feedback about that interest, the more likely that is to become available sooner than later.
Okay, so I think that leaves us. All that's left is for me to thank the speakers and the audience for their questions. I found the talks rich and very fascinating, so thank you very much. I would just like to highlight that there's the closing Microsoft Research and Xbox Fireside Chat with Peter Lee and Kareem Chowdhury, which will continue at 1:30, and there should be links available to you. So with that, thank you everyone. I hope you have a lovely day. Enjoy the last chat of the conference, and with that I say cheerio.